Throughout history, there have been many people who are small but still make a big impact, like the smallest president in U.S. history, James Madison, at only 5 feet and 4 inches. There's also the prestige boxer Manny Pacquiao from the Philippines, who's only 5'5" but is considered one of the best boxers in the world. Gamma rays are similar in that they have a very short wavelength, but they also have a lot of energy. The electromagnetic spectrum contains all the types of waves that can travel through a vacuum. This includes radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays, and gamma rays. Gamma rays are the smallest and the most powerful. They can measure anywhere from 3/100ths of a nanometer to 3/1000ths of a nanometer. Just to give you an idea of how big a nanometer is, a sheet of paper is about 100,000 nanometers thick. Gamma rays also have no mass and no charge, and because of its small size, they can travel at the speed of light. Gamma photons have about 10,000 times the energy of a visible light photon. Gamma rays are even able to penetrate human tissue. Dense materials like lead have to be used as protection when gamma rays are being used. Gamma rays were discovered in 1896 when French physicist Henri Becquerel noticed that uranium was emitting some invisible waves similar to X-rays. He was right. Gamma radiation generally takes place when a radioactive nucleus is unstable and energy is released. As you can see here, cesium-137 is decaying into barium-137 and is releasing gamma rays in the process. It can also be emitted specifically through alpha decay and beta decay. As well as being remarkably energetic, gamma rays are also very useful. Gamma ray emitting isotopes such as cesium-137, technetium-99m, and cobalt-60 can be used for cancer treatment, measuring soil density, pasteurization, sterilization of medical equipment, and many other industrial and medicinal purposes. High-altitude balloons and satellites are used to see gamma rays in space by many space exploration organizations like NASA. Gamma ray telescopes can also be used to see gamma rays by using a method called Compton scattering. This is when a gamma ray makes contact with an electron and as a result loses energy. Scientists can use gamma ray imaging as an alternative way to explore new phenomena. In addition, flashes of gamma rays that occur after highly energetic explosions called gamma ray bursts can help scientists determine the age and size of the universe as well as how fast it is expanding. Can also be very deadly and destructive. Overexposure to radiation can cause acute radiation syndrome, most commonly known as radiation sickness. Although the symptoms like itching, ulcers, vomiting, nausea, and diarrhea may seem
Radiation plan is devised of
leading to internal bleeding. There is no cure for this illness, and treatment of even the least severe cases can last for up to 2 years. But as deadly as ARS is, it is also very rare. The only major cases of radiation sickness were after the bombings of Hiroshima and Nagasaki. The Chernobyl disaster.
The one in front, yet decimated. This is what it looks like when a wave of
earthquake in 2011 that damaged a nuclear power plant on the east coast of Japan.
Good, relatively non-invasive way to
Exposure to CT scans and X-ray machines.
Oh no, the front! Wait, stop.
If you stay outside for too long on a sunny day, you will most likely only get sunburn. That is because the Earth's atmosphere will absorb almost all gamma radiation from outside, so most of it stays in
planets
space.
and even gases in space.
However, outside of Earth, there are many different sources of gamma radiation, including
The star's outer layers are blasted away in the
star, which is the small, incredibly dense.
Can't send humans anywhere near a black.
The most interesting objects throughout our universe, a portion of their light as gamma rays. However,
gamma ray bursts. As mentioned before, GRBs are high-energy flashes of gamma rays that last anywhere between 10 milliseconds to a few minutes. Although they are short, a gamma ray burst releases more energy in 10 seconds than the sun will in its entire lifespan. Gamma ray bursts would probably be extremely harmful to Earth, but they only happen once every few million years in the Milky Way galaxy, and once every several hundred million years within a few light years away from Earth, which is approximately 5,878,499,810,000 miles away. The last of this phenomena to affect Earth was in 775 AD, although it isn't certain. In conclusion, gamma rays can be very useful and are instrumental in the progression and development of our society. That being said, they are also very dangerous and powerful, so gamma radiation should be dealt with by experts only and with extreme caution. Just remember, everything should be consumed in moderation.